All right, so here we have a typical industrial fan. And why I brought this into the picture is because most people know how powerful these fans are, and we have a wind gauge here. And so what I'm going to do is turn the fan on and see what kind of velocity it has. It's got 3 speeds, so we're going to put it at the maximum speed. And you can see it's about 18 miles an hour. So that's the force of this at high speed. That's the highest of the 3 speeds. So you get an idea of the wind velocity. So the first fan is the Lenel fan. Now keep in mind, this manufacturer claims that they have a 130 mile an hour velocity, which I found a little unbelievable, but I bought it anyway. Well, it turns out, well, you'll see how it turns out. So here's the Lenel fan. This is the side that is actually pointing to the hot cylinder, which is the rear cylinder on the Harley. It's hidden, so you're only getting a little bit of the fan. That's why it's going up. If you go right where it's wide open, this is actually what's hitting the motor. And it looks like it's about 4 miles an hour. A little different than the 130 mile an hour claim that they make. So that's the test of the Lenel fan. Cooling system we're testing are the love jugs. And as you can see by the string, everything is exactly the same as when we did the Lenel test. So it's all zeroed out. I'm going to turn them on. We'll see what happens. We'll move it around a little bit, showing 20.6. So it looks like a pretty steady reading, close to 21.5. Alright, so that's the wind velocity of the love jugs. There's no sense doing the other fan because they're identical. Alright, this is the Harley-Davidson cooling system. And you can see the gauges zeroed out. And you're going to find something really interesting, at least we did. Now, when we go here to the center of the gauge, you can see it's running about 5 miles an hour. However, that's not blowing, that's sucking. Now watch what happens when we move it to the outside of the fan. You'll actually see the wheel stop. See, it's going lower and lower. Now the wheel is actually stopped. If you can look, see the wheel. It's actually stopped. There's no wind in or out. It's a neutral wind right there. And now we go to the outside of it, and now it's blowing at about 12 miles an hour, it looks like. 13 miles an hour to give it the benefit of the doubt. And now when we bring it back, this is what we found pretty amazing, is the wind slows down dramatically, and then it actually stops, reverses, and now it's sucking air in. And it sucks air in for a far greater distance on that line than it's blowing out. Now again, on this side, the wheel and the gauge will stop dead. And you can see the wheel now, it doesn't know what to do. It's a little confused whether it should go forward or backward. And we keep it going out into the